Dear aspirants, welcome to my channel. This is an 3 marks question. So explain the difference between HI and rise and fall method. There is a difference. This is first difference, rise and HI method and rise and fall method. First HI method, it is a rapid involving for few calculation. That is HI, rise and fall method. HI method. Next, it is a laborious involved for several calculation. Okay. So second point for HI method, there is a no check of RL intermediate site. In the rise and fall method, so you have to check RL for intermediate points. The third point for rise and HI method, the error intermediate RL cannot be detected. In the rise and fall method, errors in an intermediate RL detected can all the point to be corrected. The fourth one, rise and fall method, there is a to check accuracy of RL calculation. In the rise and fall method, 3 check accuracy for RL calculations. And this system in the rise and fall, this is HI method, this system suitable for longitudinal level where the number of intermediate point cited. But in the rise and fall method, the system is suitable for a fly. There are levels where there is no intermediate site calculation. These are the 5 difference for the rise and fall method and HI method differences. So next, justify the need of checkline in the chain triangulations. Why we need checklines in a triangulation? First, before, what is the use of checkline? Checklines are very important in the chain triangulation because they will help make you sure that survey measurement accurate and liable. We need for checklines. The first justification, detecting the errors. What is the use of checkline? So while measuring a distance and angle, for example, mistake will happen. The checklines are extra measurements to be taken each point to verify the original measurement as a correct. Sometimes if it does not match, it will help you identify the mistakes if you take the checkline distances. Next, improving accuracy. By using checklines, the surveyor can confound their measurements consistently throughout the whole survey. This will improve overall accuracy of results and especially with dealing with the large areas. So if you use checklines, for example, improper accuracy, you will not get a proper reading. We can use this checklines. Based on this checklines, we can find the errors in the triangulation survey. Next point will be ensuring a liable surveying. Triangulation relieves network interconnecting number of triangles. If any triangle has error, it affected by entire survey. A checklines as backup for ensuring all network measured by correct and survey line is to be trustworthy. So we have to do in the survey in the number of triangulation survey, which is like a triangle. It is divided into number of triangles. So any triangle, if you got error, there you can use this checkline. Next is mention the errors due to natural cause in the leveling. What are the errors? One is an atmospheric refraction in hot air in the ground. Bend the light rays to make staff appear higher and lower. Okay, distorting readings, particularly in hot days, it is a long sight. Okay, if the for example hot humidity will be low, we cannot see the reading properly. Next is earth curvature. It does not flat. Curvature is not flat. Okay, it causes the line of sight fall away from the staff in a lower distance. Required correction and also minimize by the short sight distance and balancing setups. If the ground is not flat, so that time you will get a error in the curvature while taking distance. Wind, it is a strong wind also which affected by leveling of instruments and make the leveling staff is unsteady, preventing bubbles. Accuracy of bubble centering and clear the rod readings. There also it will be affected. Next will be temperature variations. If the changing the temperature, it will be affected by the instrument components and the density will be varies and line of sight will be differ from that. So next will be sunlight. For example, direct sunlight on an instrument object lens, it will not get a proper reading and Heating of staff can cause expansion. And gravity variations. The minute changes in the gravity affected by the leveling tube of the bubble. What is a bubble is there. And it will give you a minor typical surveying in this. These are the errors in the surveying. Next question will be explain interpolation of contour. So it is a process of estimation of the elevations for the intermediate point between known as a contour lines. These will help you to create a smooth and continuous representation of the terrain, extra data available between the contours. Okay, what are the steps of interpolation of the contours? Identify unknown contour lines, first one. So if to find the contour lines map known elevations, these contour lines represent the elevations. For example, one line might represent 100 meter, next line might have substance 120 meter. Okay, next measure or the distance between the contours. To measure the horizontal distance between the two contours known as a contour line, which help you to determine how the elevations changes occur over the horizontal distances. Next is estimate intermediate elevations. To interpolation, you can calculate the elevation of intermediate point between the contour lines. Instance, the contour lines is 100 meter, 100 and 120 meter. If you are looking for the halfway between, the elevation must be 110, half of that. So if it is an 100, so next will be an 200. If in between, you will get 110 meter of the elevation. If the intermediate point is not exactly halfway, the elevation is adjusted proportionality based on the portion between the two contour lines. Next, draw the interpolation of the contour lines. Once you calculated the intermediate points, you can draw a new contour lines connecting those points and creating a smooth and more continuous contour maps. You can draw it. See more information, please subscribe my channel and share and support. I am going to add more questions. Thank you.